Hello. It is time. All right, let me tell you how crazy I am. Let me tell you how crazy I am. All this, delete that. Delete that. Literally delete that. Okay. Anyway, anti-gravity forces. My thinking was anti-gravity forces would be ideal for getting the body to look right, but what it really is and what it's always been is just literally applying anti-gravity force based on the legs on the ground. That's all it's been. If there are 3 legs, and there's also, you know, a slight improvement to it, which the reference from Minecraft that I have uses, which is essentially drawing a polygon and projecting a point that is nearest to the center of mass, or I guess nearest to the center of all the legs, and using that point as the mass, as the gravity. You would take that point on the surface and project that to the center of mass, and that would be the direction that you could apply anti-gravity in, which would mean the body would move and kind of fall. I don't really need that. It's cool. It is very cool. But I think as simple as I can get it, which is just negating gravity if there are legs on the ground. So solve offset is completely going away. I'm just not doing that. Calculate body offset, not happening. Well, I mean, okay. So I actually sort of need it for the height offset, but that's not really. It can be a lot simpler than this. Those can just go away. Height offset, height motion tolerance. I could still use that. Maybe I will still use that. Sorry. Actually, I'm just going to drop it too. I'm just working on height offset. And this whole group can just go away, because now it's only the height offset. Okay. Cool. So this probably still makes sense though. What I do is I still draw the vector to each of my legs. This can effectively give me... Yeah. Maybe I do just make a plane out of my legs. There is something, solve rotation does this, where it will go through each of the legs and do a small calculation for orientation. I think perhaps what I should do is... There's something about one of the middle legs being raised that kind of prevents it from even acknowledging that. But height offset should acknowledge that. Possibly what I could do is to bring these two together, because solve rotation computes a preferred forward and a preferred right using the grounding points. And also, I think the rest position is probably wrong. I should probably use a collision point instead of the rest point. I'll just make a small... Well, hang on. What do I have right now? Save. Whoops. Body offset vector. Yeah, okay. Let me continue stripping this code out because I'm not using it. I have some things I can add. There's a debug ground vector, which... What? How does that even work? Look at this. This is the whole diff. I'm just adding this. Debug ground normal was already there. That I just never... Huh? How was that? I didn't move it. Oh, that's me writing in zeros. Right. So it disappears. I've got a bunch of random things added here. Alright, I need to clean this up. This is sort of some fix, possibly. I can save that for when I do the crawler character. I'll just ignore crawler character for now. I'm still just working on that. Well, I can add that little deletion, that comment. Yeah, I'll add that. Not adding that one. I will add this ticks per second though. Okay. Oh, this is actually more than this. Part of this is also that change. Removing skeleton advance and but I can drop this line probably. I mean, I guess I can add the manual input handling because those will all split nicely. All right, I'll do that. Okay. Now that's all just body offset stuff that I'm not adding yet. This is all like the real fixes that I was trying to go for here. Okay. That's what all that stuff did. And now it's all sent. Well, it's... Now it's all sent. Okay. So I've got left is this silly stuff. Oh. I meant to add that. Whoops. Well, great thing about it being only me, I can just do that, amend, and push. Okay. Okay, now I'm just doing body offset. Great. So I did have calculate body offset, solve offset. I kind of think I want to do it as desired acceleration because otherwise it sort of becomes like a friction thing. I can also make it part of the spring force. Well, hang on. How does character work with spring? So spring is calculated in here. Spring calculate force. Oh. It just adds it right here. If we have a spring, we obtain its forces. I could use an actual shapecast spring. I could do that. Though I feel like it might make it way too bobby. If that makes sense. Here's desired. The reason I might want to use desired acceleration is because it sidesteps this friction thing, where, well, yeah. Here's the thing: ground velocity is 0. Technically, it wants to stop, which means. Well, wait a second. Relative ground is ground velocity. Take ground velocity. Take the vertical component of ground velocity. And then add that to the ground relative contact velocity. What? That looks really strange. Why does it look like that? Because I think ground velocity is just sliding out the ground normal. Oh, but this isn't sliding out the ground normal. This is sliding out my up direction. So this is taking the ground plane, the y component of my y component of the ground plane, and then adding that to my relative contact velocity subtracting the ground, subtracting my up. Oh, this could get... Okay. I think it's really quite a lot simpler than I think it is. I'll just do solve height offset. Yeah, I'm just gonna get rid of that one. I don't think I really need to see this. I'll leave it there. I'll leave that part because I just don't know if I'm going to use that. Okay. Yeah, what I'm doing is I'm taking every grounded leg. And then... Oh, well, this isn't, wait. This isn't even an anti-gravity force. Hang on. I need to be solving anti-gravity first. That's how crazy I am, by the way. I keep doing these things that are, like, ahead of that. Yeah. Use a spring-like force to keep the body, I guess the center of mass, some distance away from the ground. I could literally use a spring, by the way. I actually could literally use a spring. I'm not. And maybe what I'll do, since I'm using some of this stuff, I might pull this out, because I'm going to do this again, sort of like this, but for the other ones. Yeah, that's main legs, right. Right. I mean, I can just do it again. It's not that big of a deal to just do it again. It's also a little bit different. All right. Solve height offset. So I'm trying to keep the center of mass some y component distance away from the average, I guess, leg point. So I could say total offset is the leg target position end minus start. So from there down, perhaps I should go the other way around. If it's end minus start. Oh, wait, no. Wait, yeah, it is end minus start. I'm drawing a vector down. No. I'm right. Oh. Please. What was that? Like target position? Because I want to have a want to draw a vector up. So up means I have like a positive 50 centimeter offset, and I will slide out my desired offset from that vector. Right? So if I'm over that, it'll be pointing up, which means I'm higher than I should be. When it points down, it means I'm lower than I should be. Okay. And I do want it like this. That just didn't make any sense what I just did there. Okay. So total offset will be really on this vertical component. Yeah, my vertical distance from each of the legs, And then I offset by this. So now my body offset is a vector and length, or is a direction and length. And since I'm doing solve, I don't really need to have body offset here. If I had no legs, then I cannot do anything. So we're just done there. I'll call this average. If I can find the G, average offset. And I guess I can actually call this spring direction. And then if this is 0, also, if I'm always dotting by this, then my spring direction is actually up, so I don't know why I'm doing that. Alright, but now I'm going to look at how I do springs. Okay. Normal direction. Normal. Collision normal. Okay, so I don't have a normal. I guess I could. No, I won't. I don't care about last length. I do know a speed, so I'm providing a speed. Whoops. So I'll just say... yeah, I guess I can just say length. Length minus max length. I just need to make sure I get length definitely correct. And then my speed would just be my speed should just be the relative contact velocity speed in this direction. Actually, right, if I'm doing that there, then I need to run this at the end of here. Because I think what I actually should be using is my ground normal direction, my relative contact, my ground normal dot with the relative contact velocity. Let me check what character controllers passes to this. What speed does it give? Ground relative contact velocity dot the spring direction. So the spring points down, then I change it to be pointing up. Okay. So this is effectively ground relative contact velocity dot ground normal for crawler character. which I will compute ground normal to just be the average ground normal of all the legs. I don't have last length. Normal is what? Normal is the ground normal. Okay. Direction is a vector pointing up. I think this is probably where I'm meant to be using the average plane instead. Taking a plane and averaging that vector. I think cosine theta is just always 1, actually. So I can just drop that out. Now the offset still is weird. Length is some positive value, right? It's always some positive value times the max length. So it's just that. So length minus max length. So if the length is less than max length, then length will be negative. Honestly, maybe what I do is I do this. I do average offset length, and then I do this. Because I know offset is always going to be like this, a single vector in this direction. I mean, since I know this is just always in that way, I could just take this off and just have this calculation. So these should be pointing in the same direction. As long as the legs are below me, it should be positive. When legs are above me, it's going to be negative. And I guess this could be length. Maybe I call this length. And then this will be offset. This will be speed. And then I do have these two things. So I guess this can become a group again. And I'll just copy these. Also, this ranges to 2 and then to 1. Okay. Okay. And then now I have the force. And up here, what I do with that force is I do total force times inverse mass times step. Okay. All right, 1 second. I'm back. Okay, direction. So that's just gonna be Y. And there I go. That should be that. I do not currently have a requirement for the number of legs on the ground. So I guess that's probably what I should do though. Because the force will be multiplied by that. So I guess I'll calculate here. Choose a smaller value between 1 and count over. Count times 2 and legs over size. So if I have half my legs on the ground, that's enough. If I have should this be like spring force times leg force? I guess it should be, right? Well, this is like a spring in contact with the ground. So if I don't have any legs in contact, if I have fewer legs, then I have less damping, right? Wouldn't that be the case? Okay, let's see what happens. Nothing has happened, which I'm thinking just means I am doing some anti-gravity somewhere right now. Oh, it's not that I'm not doing anti-gravity, it's that I'm not even doing gravity. That's it. Wait, integrate forces is supposed to be adding gravity for me. Yeah. Integrate forces adds gravity for me already. Or is this ground? No. So it's just working right now? Yeah, that's weird. Oh! I remember. I set gravity scale to 0. And its legs are messed up. Whoa. Why are your legs all a little weird? Oh, goodbye. What the hell? Okay. What have I done wrong? Is it something around here with this? Let me just cut that out. I'm not sure why he accelerates off. It's got to be the stopping thing, actually. Also, it does its legs really strange. Its legs are moving weird now. So what's it? It 100% has 3 legs in contact with the ground right now. Oh, okay, there it goes. Why did he take off backwards? Is that really the stopping force that I did wrong? Yeah, I'm not sure why it's doing this, but it did fall down and stand up. I saw that happen a few times. If I get it really twisted around, it will fall down and then somehow eventually gets back up. I mean, maybe I have to help it sometimes. Oh. I mean, if these legs are in contact with the ground, I don't know why it can't stand up here. I'm not sure why it's not doing that. Yeah, I feel like in this case, these legs are in contact with the ground. So why is it not doing that? If a leg is moving, honestly, let me just say if the leg is not grounded. If the leg is, even if it's like moving, but it's still in contact with the ground, it still definitely is able to. Whoa. Okay. What the hell? What was that? I don't know what that was. That was strange. Alright, dude. Can you just like... I'm trying to flip him. What is happening now? It's upside down. It thinks it's like grounded upside down now. Alright. Yeah, this guy is just kind of nuts. Interesting thing there. That's quite interesting, actually, that this has happened. Quite interesting. Yeah, it's, you see how like springy it is when I run into it? It's definitely believing it's grounded upside down, which is just not correct. Weird. Weird. I guess I could say something where if its body is in contact with... How would I fix that? That's really funny. Alright. If I jump on you... Whoa. Oh, oh. Oh. Interesting. Interesting motion he's got going on here. He's jumping. Alright, I think that's just probably... That probably is where I need to say... I probably do have the dot with the ground normal. It also can't write it. It doesn't... It's not writing itself quite right. No. Alright, I gotta take the dog out. I'll be back. I'm back. Okay, so if the leg is grounded, I can do this. Can do yaw. Interesting. So it should have been trying to fix its up direction using that. But if those legs aren't in contact with the ground, then it just uses its current orientation to fix itself, which is not really correct. I guess what I should probably do is actually use apply impulse instead of that. Because then I can apply this per each leg, which would be more accurate. Because essentially what was happening is it should land on those legs and rotate back because of the push force. Is what should have happened. And that it would right itself really quickly. That's what should have happened. So yeah, maybe I just actually apply it per leg. And I sum up the force and the direction for each leg. Sure, yeah. I'll try that. I'll just use force application on each one of these. And each leg will be able to apply I guess what I should do is probably count up. Oh, wait a second. All right. I think what I do is I calculate the amount of force that I want to apply total, and then I split that equally along all the legs that are in contact with the ground. I think that's what I do. So I'll undo this a bit. And I think it's just bringing this down, and that's kind of it. All right. So I get the full, I guess I still need leg force, right? And then I will take this force and split it equally along each leg. I don't know. I mean, it seems okay. It seems right to me. I mean, I can sum up the... It's more like the direction is... It's that leg, it's the leg ground normal. I mean, actually, there's kind of nothing really wrong with just making each leg its own spring. It's more about the force point. Okay, so I do need the force point. So what I'm gonna do is compute some attachment point. Oh, what is it? Like initial location of... this point, right? Yeah, okay. It's just being stupid again and being like, oh, I don't know what this is because I can't compile my parent class because my parent class can't compile me. It's just silly Godot stuff. Okay. Attachment point will be this legs. Yeah, global position. It needs to be relative to the body without any rotations applied to it. So I could just do I guess I can do my global transform. I can do that. And then this will be the origin point. I'm thinking I probably need to do that for like rotations and things. Well, yeah, if I turn, okay, yeah, if I turn on top level, this is the position that I get. Okay, so it should be right. So I just want to see that for the front leg, I'd be that value. So let me just have this print out. If index is 0 at the attachment points, and then I'll do breakpoint. I just want to see that this is correct. Yeah, that's what I expected to see. These two vectors line up. And that should be regardless of orientation that I make this thing have. So if this were to have this weird orientation, I would get just the exact same number. Okay, pretty much the exact same number. There's, you know, floating precision error, but that's just literally the same number. All right, cool. Attachment point, good. So I compute a split force. And then I just run through the legs again and do the same thing again. Yeah, it should just be apply impulse or apply... impulse is time independent. they say I should use force otherwise. I think this just means I can take off. I can just do literally just total force. Total force times leg. Oh. I don't know the ground normal of the leg. Why do I not know the ground normal of the leg? Why do I not know the ground normal of the leg? Okay. Now I have the ground normal of the leg. And this should be split force. Ooh, it fell down convincingly, although the legs are, you know, very weird. It should be able to stand up. It's definitely got some weird thing going on where... What? It's definitely got some weird thing going on where it really likes to... How are those not pushing it up right now? How are those just not pushing it up? That doesn't make any sense. Okay, have a normal orientation. Are you joking? What is that? There's some weird stuff going on with the legs and like trying to do stuff. How is it rotating right now? Those legs are not touching the ground. I don't need the print and the breakpoint. Why is it doing this crazy rotation thing? All right, well it's not rotating because of that. It's definitely just some dumb thing where the leg points aren't tracking and then they're not updating. I don't know what's going on with that. If they're already on the ground, then they're fine. Or I guess if the springs are already in contact with the ground, then it's fine. But falling is clearly not working. In fact, it looks like it's just straight up not working at all anymore. I don't know why. What? What? I can only imagine it's because I just did this, where I made ground normal be this, and now it's just totally broken. That's the only explanation that I have. But that doesn't make any sense. I don't understand what's going on. I can't even pause it quick enough. Dude. It's so weird. Why? Okay. Let's see what's going on here. Alright, so length is... So I'd expect to see this say like negative 0.02 for offset. And then speed is probably something. Speed might just be a 0 right now. Okay, it's not quite 0. Yeah, I don't understand what's going on with the legs. They just really don't want to move. Hi, Yulia. It's been a while. How's life? It's going fine. Somewhere around here is when it decides how it decides to move the legs at some speed. For each leg. Use a very small leg speed while interpolating to rest. If body ground direction is not 0, this means we're moving. As we have a desired forward, we use this. Guess who's on this vacation? You? Robot game, yeah. I've just done something and I don't know what. Now I'm just confused about what could be making this just not do anything anymore. The only thing I did was I moved the force application to each individual leg. That's all I did. So instead of applying the entire force to the center of the body, I apply that equal amount to each point around the body. I mean, I guess I change it back and see if that just fixes it. No. Would be annoying now every time. Okay. What did I just change? Like, really the only thing I did was I went in here and I said I changed that. But now it's like none of the legs are grounded anymore. Why does it say it's null? This is just a little bit annoying. I'll just fix that. I'm assuming it's not like that here. Okay, how dare you? What? What did I just change? Is it that? That little... No. Needs to be here. I guess it was that I'm using state apply force now. All right. Okay. So this is the mistake. Somewhere between this line and this line. These two lines are not the same. Why are they not the same? Okay. I'm going to look at Git source code. Godot source code. And see what silly assumption I've made about what this means. I'm wrong. I'm wrong. Something about this, I'm just wrong. I'm just wrong. I am not convinced that I'm wrong. But I'm just wrong. Somehow I'm wrong about what apply impulse does, or apply force does. Somehow I'm just wrong. So it calls body, apply force, body, apply force, a force in a position. Body, apply force. Tough. It's a jolt body 3D. Is that in here? Jolt body 3D, apply force. Yeah, it must be because I know that jolt's apply force is, yeah, it's like that kind of capitalization. Jolt body add force. Oh, maybe it's because it's... No, because when I... Okay, let me just look forward here. Because I don't do inverse mass and I don't do step. Because what this should be doing is it should be doing like linear velocity increase and then angular velocity increase. And those would be based on some kind of multiplication with whatever it is. I don't know why, unless I spelled it wrong. It should definitely pull this up. Okay. Body interface add force. Body interface. I don't think it's that one. Add force. Add force. Add torque. Does anyone know how to write searchable code? Oh, hang on. Wait, what? Hang on, what? Oh. Get accumulated force through add a force calls. So I guess I should look at get accumulated force. All right. So I do update linear velocity plus inverse mass times get accumulated force times delta time. So it should be the same thing. It's linear velocity plus step times inverse mass times force. It is the same thing. So I don't know why these are different. Why that one doesn't work and this one does work. Does this not happen if I do manual integration? Is that what happens? I call apply force and it doesn't actually do it? That might be it. Apply force, torque, and drag internal. I think it is because this includes gravity and okay. Can I do state I think calling impulse does it right away. That's my thinking, is that impulse will set it immediately. Let me see that. Whoops. I guess I'm looking for body. Apply impulse, probably. And it just calls back to apply impulse. Somewhere in Jolt world. Add impulse. Okay. Set linear velocity clamped. Okay. Yeah, all right, so it calls it right away. So if I do apply impulse, then I get this, though I should, I have to delta this, so I can do that. All right, same result. Okay. Split force times the leg ground normal. Times... Well, split force will just be that. And then I want to apply it at the leg attachment point. And take this one off. Weird. Alrighty. Alrighty. Okay. Well then. And we'll walk into this one tick at a time. And push it. Alright, it rotates, and then it's... that's just crazy. Alright, I'm assuming I probably need to, like... Oh my god. Yeah, that's just... Dude. I can't believe what I'm looking at. I just can't believe what I'm looking at. Okay. Huh. So... So... I don't know what to do about that. I would say it's definitely... Okay, so I give it a very small push, and it seems like as soon as it lifts a leg, it goes flying. Because it can't... No, why is that? Maybe I just have the spring force wrong. No, I definitely don't have the spring force wrong. I definitely don't. Why does that happen? It was working before, but now if I move it... Yeah. Oh, jeez. All right. I'm looking for a leg to detach. All right. I've got 2 legs off the ground. 3 legs off the ground. And it's... Ah, right. Okay. It's pushing unequally. Yeah, okay. That makes sense. I understand now. There must be some way that I can calculate how much force it should apply based on how far away it is from the center of mass. Not even that. Or maybe that would be the solution. But more, it just gets in the case where I have a tripod shape. And I'm applying 2/3 of the force on this side, so making it turn this way. And then 1/3 of the force on this side, making it an overall... this rotation happens. Is that correct? All right, so these legs, so I expect it to be rotating clockwise in short order. It is rotating clockwise right now. And then it just kind of goes really insane where these 2 legs are grounded, but for some reason it's not rotating it back. It builds up an insane amount of force there. Okay, so why did that happen? It's possibly this. maybe I'm just meant to use the leg. I guess I do want to unlike the leg normal. Maybe this should just be ground normal. Yeah, this probably should just be ground normal. Yeah, it starts to accelerate like crazy. Like, these legs are technically in contact with the ground, which should be rotating it the other way, but they're just not. I guess now, because it's underneath it, yeah, it should actually be pushing this direction. This direction. Ah, okay, maybe that's it. So it should be pushing in the direction, I guess the leg up direction. Yeah, so it should just be pushing in the state. State basis what the hell? State transform basis. Oh, why? So initially I expect to see it rotating against or with the two legs that are grounded. And then these legs should land, and it should... All legs are in contact right now. Yeah, those two legs should stop it. And they've only accelerated it. So... Hey, Danilin. Sup chain bastard. What does that mean? Yep. Alright, I think I'd probably just say... Wait, apply impulse... Offset from the body origin and global coordinates. Oh, should this be state? Maybe that was part of it. I think it's still probably wrong, but I just think at some point something should go better, and I shouldn't see it accelerate to infinity. Better. It's super duper wobbly, but better. Hey, don't freak out, don't freak out, don't freak out. It's not freaking out. Okay. Alright. So what do you look like in motion? Still probably crazy, but you're not, yeah, I mean, that's just insane. It's just insane. Aw. Wow. I think I need to make this simpler. How can I make it simpler? I still need to be the case that if it lands sideways, it's gonna fall like this. Right? Maybe... Definitely... Okay. I think somehow I still need to... Hang on, solve height offset happens after solve rotation. Maybe I should solve rotation... No, because solve rotation is just the same thing. Nothing has actually moved yet. I could multiply it with the cosine between my up and the ground normal of each leg. Or the average ground normal. No, it would have to be... Oh, no. No, 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 no. Alright, this is too much. This is kind of the last step, though. Untie the spider from stepping places, make them individual, but they work together. That just means nothing. What you just wrote. Dumb, I faced that problem before. I just, like I said, okay, so the real problem I'm trying to solve is the spider lands like this, right? Let me just not even call. I totally skipped this call. All right. I mean, it's writing itself slowly, but I think it's just because of rotation correction, and it's not getting there all the way. You're right. So what the Minecraft version does is it essentially draws a polygon between all the like contact points and traces a vector from a point on that polygon closest to the center of mass into the center of mass. And it uses that to counteract gravity. I'm using a spring, which just has a set height and then a stiffness. Which actually doesn't counter... yeah, this one actually doesn't counter gravity still on a wall. It'll keep its height offset from the wall. My only assumption is that offset becomes something insane. Like some very, very large value. In relation to this. Make the spider and the stepping thing two different entities working together. What does that mean? I have a rigid body. That's part of the physics simulation. In some way, it has to use the fact that its legs, which are physically in contact with the ground, are able to keep it off the ground. So that, you know, in theory, if I were to remove a leg by shooting it, it will lose its ability to walk in some capacity. And ideally, it would just look like it's, you know, like a robot would look like if it just thought it had a leg, but it didn't have that leg. You know, it would take a step and then probably fall sideways a bit. Maybe it would correct itself. Maybe it would be too much for it and it would fall over. Whatever happens, if it's physically simulated, then I'm okay with it. The issue is I have this thing blasting off like a rocket from the ground when it has like a slight deviation from what it wants. Like, how does that make any sense? That doesn't make any sense. That doesn't look right. It's breakdancing. I'm trying to think, is there a way I can make it simpler? Or what's wrong with my current approach that makes it look like that? My suspicion is offset becomes something ridiculous. Obviously, the spring force is wrong. Let me just reset it. Like this time it kind of like kept itself. Of course, and as soon as I Alright, go again. Alright, now what do you do? Why do you go insane here? Why is that like not in contact with the ground at the back? Oh, now it is. I mean, I guess the mistake here is that I'm applying this force equally to this leg and this leg, when probably most of the force should be on this leg and less of it should be on this leg. Did you say you have an idea and you're just sending me a video that I'm presuming is not going to provide any ideas and it's just going to be a demonstration of someone already doing this? Yeah, that's just gameplay. Do you know how they made these? This is 100% animation. There is no simulated physics at all in any of that. That is literally just a ton of animation stacked. A ton of stacked animation. This leg says it's not in contact with the ground. Why? Why does this leg say it's not in contact with the ground? It obviously is. Something wrong is not right. Okay. Possibly a mistake is that I'm trying to mix between... I mean, I'm mixing between rotations and height offset. That's what's happening here. Technically, this is doing rotation. Now, rotation actually already handles when it has a velocity in that same direction. So that's technically it's resilient to this adding rotation, because then it will just say, all right, let's slow down our rotation. Should I just count up the grounded legs? Like, I don't know. How would I? Okay, I'm building this thing for real. How do I make it so that I have a decisive way of how much force to apply at each leg point, based on its orientation and where each leg is? One idea is I could look at the rotations of each leg joint, compare it to its rest position, and maybe that tells me some information about how much force a leg would like to apply. Because if it's really close to its rest orientation, then it probably doesn't want to apply much force. But if it's really far, like it's outstretched flat, or if it's like, I mean, I would also say complete vertical, but probably not even that. Basically, if it's just outstretched. Get from the other legs. If it makes a lot of force on one side, it probably doesn't need on the other side. Well, what's happening is that when it takes its first step, it has two legs on the right, and then one leg on the left. The two legs on the right are getting 2/3. They're all sharing the force. Not really. I calculate the amount of force I need to push off the ground. And then I split that equally between all three legs, which means the two legs on the right are going to start making it rotate really hard. And then the body drops, and then I am adding more force, and then those two legs on the side are twisting even more and pushing it into the ground. Right? So it just kind of gets ridiculous really fast. someone 20 years ago had that same problem on the PS2? I don't think so. I'm pretty sure physics simulation was literally just like grenades and ragdolls. That was physics. Totally like non-interactive, non-intelligent systems. You had a ball and it falls to the ground. I have a thing that needs to... I mean, not needs to, but at this point I think that's what I should do. Is that it effectively will balance itself off the ground. I mean, this is a robotics problem, so I could probably look up how to do this, or how it's been done. But I think at this point, probably a lot of the state of the art, the modern approach is to train a neural network to do this, and not do any coding at all. Just try to like code up some inputs that you think it needs to know, and then request like a force output or something. Or not even that, but just request like rotation for every joint, for every motor. And then they would run that in a physics simulation for a couple days, and then they would just slap that on the robot. Is what they would do. You are insane. They're insane. We're like forgetting how to do stuff because at this point we're just having the neural network learn how to do it. And then we have no idea, like... It's literally growing code at that point. Instead of just writing probably the few hundred lines of code to do it, you would let it run for days in a simulation, and then you'd use whatever neural network came out as your robot. Seeing all means complication. The main issue is the rotation, right? If I were to draw a polygon and fit a point inside of it, I mean, how does he do it? That's what he said he does. Yeah, this is just crazy. Normal, copy, subtract, normalize. What in the hell is happening there? Nearest point in polygon. What do you think that method is defined? Where do you bet that one's defined? Utilities or math? Oh, better yet, where in utilities? Oh, there it is. If point in polygon accelerates just straight up. Yeah, that makes sense. Map a list of grounded legs to end effector. Target dot position. A vector 3. Vector. Okay. Left plus right reversed. Okay. Seems pretty simple, actually. Counterclockwise? Yeah. This is probably what I meant to do. This kind of masks away having to compute an individual force for each leg. The legs will just share the best force that they can, as close to the center of mass as they can. All right, I'm just going to go with this. Center of mass is the average leg point. I interpolate halfway to my position, and then I add 0.01. I mean, that's just weird. I have the exact center of mass. So grounded legs is going to be legs in polygon order. which are grounded. And then polygon center Y. Okay. If there's only one leg on the ground, the normal is end minus start. So it would be a vector pointing from that leg to the center of mass. Okay. They do calc normal, right? They have to call that. Oh, normal is calc normal. There it is. Okay. Normal acceleration be equal to capable acceleration, fraction legs grounded. Yeah, okay. If the horizontal acceleration is too high, we stop. Okay, so this just means if we're trying to push to the side more than up, then we give up. That's okay. Seems okay. So the spring force is essentially calculating I will be using apply impulse, but it's essentially calculating a central... Is it? Okay, so this method is a little bit different. It's actually calculating the direction to push the body in, which means if the center of mass is outside of this polygon drawn by the grounded legs, then the body will move up in this direction, and because of gravity, it'll just, you know, it'll stay still, but it will move slowly that way. Which I actually want to have rotational stuff, which means I need a force with a... I need a directional force and a position to apply it to. So I guess what I could do is I could calculate that normal as the direction, and then apply it to the average contact point. Or rather, it would apply to the average contact point, but also still doing that polygon thing where if the center of mass is within that attachment point polygon, then I just apply it there straight up. And then if it's not, I just get the closest point, and that's where I would apply it to. So the result is that the legs would still do their best to share that force proportionally well. Okay. So I won't be splitting the force. I just need to have a direction here, and then I have a point. Make your own engine? Someday. Maybe. The issue with game engines is that physics and rendering is just such a hard problem on its own that doing it well would literally take years. I mean, honestly, I do like jolt physics a lot, so I'd probably just use jolt physics. Then I can, I don't have to think about physics anymore. Make it have floating trees like in Crimson Desert. I've not looked at anything for Crimson Desert besides like one of its trailers or something. Or no, it was some video of some guy like showing a bunch of footage and then talking about the game. But he also just never really said anything super important, and he edited it so much that there was barely even a breath between anything he ever said. So it was just constant background noise. I just totally tuned it out after like a minute. And I was just looking at the game. Only thing I looked at is that it got cracked. Oh my gosh. It got cracked on day 1, protected by Denuvo. Whoever's working on Denuvo is a saint. It seems like they must just be working with people to make sure it's cracked as soon as possible. Or the whole thing is just that incompetently made that it is actually trivial. There's probably been like some kind of automated script to do it. Okay, so I'm looking at grounded legs in polygon order. Effectively, yeah, it would be like some sort of sorting function, right? A and B. Turn true if the first one was removed before the second one. Yeah, honestly, let me move this up here. No, 0. Even numbers are left, right numbers are the other way. Okay. So if A is a left leg and B is not a left leg, I return true. A should be before B. Actually, I'll do this. This is a bit better. If B is left, then I do that. Otherwise, they're both right. So I'll say both right. And then here, both left. Oh, geez, Yulia, what are you doing? 19 De Novo games got cracked yesterday. They don't even bother with cracking it. Bypass it by spoofing its calls. Yeah. Hopefully one day they just make it illegal for software to attempt to detect the system it's running on and stop itself from running. Hopefully they just do that. Take 9 to 18 months to have a de novo game cracked, not, or now you just virtual box it. So they both left lower index first. Okay. I mean, I guess I can just do count up here. Uh, Plus you give permission to dubious drivers from strangers. What? Okay. We can't be typing stuff like that. Danilin. Danilin. Alright, what's he doing here? Here. So Lake Polygon is just their... I've been thinking about this. So what happens is... Dog. Wait, I set it to 0. Hang on. Is this correct? Oh yeah, physics is 0, which is weird. That idle is 1 and the default is not 0. Dog, there's no way. It's actually not been an hour. I know, I'm pretty sure I let you out less than an hour ago. No. No. Dude. Why do you do this? Why do you do this? Why? I gotta take the dog out. I'll be back. I'm back. Okay. here. So he gets all the points as a polygon, and then he centers the average. If they're grounded, the center should be in the direction of the average up. The average ground normal. So I'm just going to assume that ground normal will be calculated like that. Polygon center Y is used here to produce a vector. Normal, so I guess as a direction, and then origin. I don't understand the center of mass because it's always just center of mass. It's really weird. Also, contact polygons. I mean, maybe that's all just there for like render or like a debug render, perhaps. But normal is definitely a direction. Then origin. Nearest point, polygon center Y. Okay, no, I get it. All right, so normal is just a direction. This is still just purely based on a direction of force. And then origin, I would assume, is the point that you're supposed to be applying it to. Okay, so the concept is just simple. I'm finding a point nearest to the center of mass, and then on the polygon. And it's actually supposed to be a 3D polygon. What did you say? What did I say? I don't know what I said. Possibly what I can do is there might actually just be a polygon. Well, it definitely is. But I might have... convex. I need concave. Yeah, okay, this thing is just stupid. I can't repeat it. Okay, then don't repeat it. What? Polygon occluder 3D, a flat 2D polygon shape. Okay. Point mesh. Oh. I think there... I can't remember. Does... Does Godot have a way to provide a list of points and produce a polygon out of it? Because if I just give it the edges of the polygon, then I get. What am I trying to do here? What am I trying to do here? I effectively have the polygon. I need to find the point inside of that, which is closest to, I'll just treat it as a flat plane, or the whatever. You can have an array into a mesh. Yeah, I know that, but I have to... I need to know if that's a thing at all. If this has a way to like query and say, give me the closest point here. I don't like it. I don't like it. I want something simpler. But I still need it to, if it's got 3 legs on the same side in contact with the ground, I need it to topple somehow. Like maybe there's just some better, more accurate math that I can do, where in the case that I have the tripod shape, I can do some sort of analysis there to say, all right, this leg has this vector, these legs have this vector. What does that mean I should do, right? I should probably apply more force on this leg to get it up. And then these legs should probably apply no force at all because they're overextended, right? So they should drop. That kind of thing. But in a way that the individual leg can calculate that force, not knowing about any other legs that exist. Like, essentially every leg will could essentially just look at its vector to the center of mass, know where it wants to put the center of mass, and just do its best job to apply some force to get the center of mass to that location. I think that probably just requires too much. Whoops, I had this open. It causes problems for my computer when I leave Krita open. But I guess this time it was fine. Normally what happens is it like corrupts memory or something. Specifically images. It corrupts image memory, and like the background and fonts are all like noise. Just color noise. Let me just model it, alright? So here's the body. Here's his current orientation. I'm looking at it from the side. And I have this leg on the ground here. And here's the ground. Okay. So here, somewhere around here, roughly, very roughly, is that center of mass, right? So I guess what I do is for this leg will draw a vector from the center of mass down to, I guess it can just invent a fictional plane, perhaps. So all the leg really knows is that there's a normal here. So maybe I just say, alright, this leg has a fictional plane that is this whole, all of this. So it draws this vector up to the center of mass from this fictional plane that it's produced, using only its normal collision. And it determines that this is where the center of mass is, and it determines that it would like it to be up here. It would like the center of mass to be up here. I'll just put this here and then like shift drag it over. Right? So the leg knows about the body, it knows the center of mass, it knows where it is attached, and it knows where it is on the ground. So my idea, looking at this myself, I can see that this leg should pull into the ground. This leg should pull down, because assuming well, I mean, really, if I really look at it, this leg can't do anything to affect the center of mass. Okay, so maybe each leg needs to know about its pair. Its diagonal pair. So now this leg knows that there's another leg over here. I would think it would just treat this like a pivot point. So it says, it could assume, all right, we're going to pivot about this point, this contact point, or this attachment point of this leg. So whatever force I apply is gonna pivot on this point. Which, I mean, that doesn't really work. This doesn't work, right? If it were some weird thing where pulling down here would push up here, then that would work, right? This would pull down. Actually, this would leave it where it's at. And this leg should push up. Okay, so maybe it doesn't know about the center of mass. Maybe it just knows about its attachment point. If it knows about its attachment point and where it would like the attachment point to be in vertical space, then it would do nothing because this is already where it should be. Right? So this doesn't have to know about the other leg in that case. So this would say, let's not do anything. This leg is fine, right? And that would actually solve the rotations too, because then if it applies too much and this comes up, now it says, all right, actually I want to pull down. I want to pull my attachment point down to meet this ideal location. Okay, so if each leg works on just its attachment point's height, maybe that's a possible solution. That doesn't seem like it would spiral out of control, even on some really crazy looking geometry where like all the attachment points are at different heights from each other. But this leg would be like, all right, I want to push my point up, and that would probably push this one down. So this one says, all right, I want to push mine up still. So each leg tries to keep its attachment point some height off the ground. The weird thing is, because this still does rotation, that actually does mean that the preferred pitch and stuff will have to change. Because now the legs essentially will do that on their own. So rotation would just be purely yaw at that point. I don't have to worry about any up. Alright, my dog is barking. Also, I've got food. I'm gonna grab food. So I'll be back in a very short minute. I'm back. One more second, actually. It's cold. All right, so here's what I'm thinking. I'm thinking I just do this. And the yaw rotation will still be on the body. I think I'll probably still put that on the body. But I can totally take off up, pitch, roll, orientation completely from completely from the body, because now the attachment points encode the pitch and the roll. However, there is an issue where if I have like 5 legs grounded exactly the same way, and then I have one leg that's like raised really high, this leg is gonna see its connection point and say, wow, I need to push the body off the ground really hard right now. So what's gonna happen is that one's gonna want to push, and the other ones are gonna get pushed down, and those ones are gonna push. So eventually, what I imagine could happen is that the 2 legs that are grounded, I mean, those would start extending. So this would say, oh, I don't want to be on the ground. So they'll pull down. My thinking is this will cause some sort of instability. And essentially I have a leg pushing, and then I have the 2 legs on the same side pulling down really hard. So I want to stop that from happening. What I would like to happen is that leg that is raised really far will say, I know that I'm like really far away, or that like my circumstance is really different from the rest of the legs. So I should say, not push as hard, right? I should be accepting of the fact, I should be more accepting that I have a difference so dramatic. And maybe that's just what it is. Maybe it takes its offset and it multiplies its offset by how different it is from the average. Or like 1 over that. Or I guess it would multiply its offset by its difference from what? I need Oh. What are you doing? Lay down. Lay down. I have French fries, that's it. He needs a French fry. How could I do that? How could I make this leg more accepting of its dramatic deviation? I guess it would be relative to... I don't think it can just be every leg. Because if I have half the legs that are good, and half the legs that are really far down, and they, you know... I guess the difference here is... maybe the difference would be... it's plane... its plane difference, perhaps? Because I could see this, if I'm looking at the creature from the front to the side, or whatever way this is, if I look at this, and I have legs on both sides, I would say and they're both on the same ground, I would say yes, both legs should do the best they can to balance in this case, right? They should both not do any sort of reduction to how much force they want to apply. This one should push up, this one should pull down. Right? So I guess what I'm saying here is the difference should be this ground plane. Let's imagine for a second that the unique leg is on some plane way up here. And just to make it, you know, less... So I'd have like... So imagine the normal legs are down here and there's one leg up here. Right? So this one leg... Did I just... What is this? What is this? Alright, I don't know what that was. That was just really weird. Also, why is this one gray now? White. Okay, and then I have a leg here. I did it again. This like click thing. This is so dumb. When I click up there, I'm like trying to deselect, but it's not really doing it. So this leg would essentially look around and say, hey, my plane is really different from all the rest. I'm gonna like either... Honestly, this leg should like totally pass, I think. Well, not totally pass, but maybe it tries to apply a small force. But overall, it will have a very small effect on the tilt. If we're looking at it straight on. So that's what I think of. How can I measure that? It's probably fine. It's probably totally fine to just let each leg do its best. Because what still will happen is that this leg will push up. With some force. And as it's pushing up, the other legs will start extending, so the other legs will try to pull down. So it will just reach this equilibrium point where, as this leg is pushing up, the legs are going to start pulling down more until those two forces balance. The two legs on the side are pulling down with the same force that the leg in the middle is still trying to push up, and it's technically stable at that point. Like, technically that'll work. On its own. However, I could do some limitations where I say, it'll take the force applied by all the other legs, and it can't do any more than 50% of that force or something, like 20% of that force. So that total force plus 20% is what it can do. Essentially, the problem here is that because the legs aren't infinitely long, that equilibrium point could be high enough up that the other two legs totally detach, and then that leg on the middle will now totally take over and essentially just pull the other two legs off the ground. Which would not be ideal. But I can also just leave it do that. I mean, I guess I can also limit the force. So no matter what, a leg can only apply up to like 10 centimeters worth of offset. So in theory, if a leg is really different from its neighbors, or all of the legs, in fact, it really could only push, if it was alone, it could only push up effectively 10 centimeters. But because it's not alone and all the other legs are going to be pulling back down to some extent, or at least two of the legs are going to be pulling down to some extent, then those ones should be enough to counteract it. I don't know, I think I probably need some way to tell a leg. Yeah, it would just look at all of its, or just look at its neighbors, the neighbors that are adjacent to it, which it could, in theory, be the first legs to pull off the ground if this one pushes too much. Even pulling, like maybe its two neighbor legs are really close right now, and this one wants to keep pulling for some reason. It should probably say, no, I'm not going to pull anymore because the other two legs are going to have... I mean, I guess in that case, the other two legs should easily overpower any pull that the individual leg could do. So maybe I don't really need to worry about that. But it would be nice to have some general solution to it so that pushing and pulling is accounted for. It should probably look at its grounded neighbors. If both of its neighbors are grounded, or maybe it actually just looks at the contact point where the legs would be if they could be grounded, and say, all right, my average point is going to be my neighbor's average point. I could do that. Would that work? Not really, because if I have like 4 legs and one of the legs are really compressed, that one should extend up. And if they're only looking at their neighbors, then the 2 legs on the side are going to say, oh, I should push up more. And so they will. But then they're already kind of at their limit, I guess. Maybe that would work. No. Because then those 2 legs push up, and that leg that was compressed is looking at its neighbors and says, oh, I need to pull down because my neighbors are too far up. That doesn't make sense. So a leg should only act on what it... If it needs to push itself, then it should push itself. If it needs to pull itself, then it should pull itself. But there's some kind of limit based on its neighbors. Somehow. Really just in the vein of not pulling the other legs off the ground. By extending too far, or shoving the legs into the ground by pulling too far. But I mean, like I said, in that case, the 2 legs should be able to overpower the individual leg. So overall, it'll move up, but also only to a point. I think maybe it should look at the offset. Each leg will calculate its offset. And then at that point, each leg can determine how much force it should apply by comparing its offset to the average offsets of everybody else. So if its offset is very different, it probably shouldn't do too much. But if like half the legs are really compressed and they want to extend, then the average will be closer to them. So they say, all right, you know, we can extend some amount. Maybe that's where statistical analysis will come in. I calculate the mean and I was going to say the mean or the average. Those are the same value. Calculate the average. And then I would compute some sort of standard deviation and then some z-scores. And then I think I would taper it off after a standard deviation. So within 1, or maybe within a half, we apply full force. And then beyond 1, we apply a linear drop as it reaches 2 or something like that. Or I could say a half, within a half, we apply full force, and then between a half and 1/2, we taper off to 0. Or I could just straight up use the z-score. And say that if we're 1, 1 will be 0 and 0 will be full. Right, so it could just be 1 minus the z-score. Or maybe it should be less than that, I don't know. Standard deviations are, they're normally distributed, right? So there's a certain statistical thing there about that, where 1 contains, within 1 deviation is like 90-something%. So maybe it should be even higher than that. Or maybe that's fine, actually. It could just be a multiplication of that expected percentage. Does it matter the sign of it? Perhaps it only affects if the signs are the same. Like if it wants to extend and it's below the average, then that's totally fine, just always extend. But if it wants to extend and it's above the average, then it would taper off. That makes sense to me. Yeah. Yeah, so only if the signs are the same then in that case. Alright. I might have cracked it. But the problem there is that I do have to take off all that rotation work I did and just go with yaw. But if that works, then now I have a totally self-balancing thing that is, you know, more physically accurate. The legs will quite literally be applying their own forces and calculating it just by themselves. Yeah, I think that's right. I should be measuring the height offset as the distance, the ground normal distance from the leg contact point to the attachment point using ground normal. So if the body's rotated like this and the leg is down here, it's going to be like, wow, I want to push up really hard because my attachment point is really low. Yeah, I think that seems better. Okay, I'll be right back. And then I'm implementing that. I'm back. All right. Okay. Okay. So let me, I'll leave body orientation, I'll leave that. Okay. So this is effectively, this is just going to straight up replace pitch and roll. It doesn't affect anti-gravity. I think anti-gravity I'll just probably do really simple, where if I have at least 3 legs on the ground, then I can apply anti-gravity to its maximum amount. If I have 2 legs on the ground, I can apply 2/3 of anti-gravity, 1 leg, 1/3 of anti-gravity, 0 legs, none. And that's just exactly what I do. I check my gravity vector, I check my legs, and I add that amount back to my linear velocity just to completely counter whatever gravity is doing. Well, not to linear velocity. It would be added to desired acceleration. I guess I can also just have, at this point, the legs apply anti-gravity on their own too. And otherwise, I don't know, maybe I could say, I think desired acceleration is probably fine. It's like a weird, it's kind of a weird thing, but I can still use that. The important part is that it doesn't affect my linear velocity immediately, because then there's other systems that are reading my linear velocity to calculate friction and things like that, which actually is probably a thing here. Well, this one's purely angular, so it's not even accounted for, but this one is wait, does this not read linear velocity? Yeah, it reads it here for air resistance, which is not what should happen. So well, I guess this is a direction, but then it does, yeah, it does read the length of it, which is a problem. Maybe that one's not so bad, because it's actually not read anywhere. It's read here after I would do desired acceleration. Yeah, weirdly, I thought I was using it for... Oh, but I am. It's a weird thing. I think I'm supposed to save my linear velocity and then read from that value for all the calculations. And then at the end, I write my results. So anything that I would be adding to my linear velocity in this step, I don't actually include as part of my ground relative contact velocity. I shouldn't do that. But it's read here. Which is technically in calculate ground force, so I don't know. It's also probably not that bad, but it probably is pretty bad to modify this before I read it. So I don't know, maybe calculate ground force should just be moved out. Or I do some kind of cache. I don't know how I would cache that. I mean, well, I guess what I can do is I can do the calculate and solves. So up here I would do calculations and then I would write integrate forces and then after that I would do solves, which will additionally modify that value. I guess that's what I should really do. Alright, so for now I'll just leave it. But I can go ahead and make this one work, so I can do calculate leg offset. Actually, since update legs does this, maybe update legs can write in this value. They can they get their normal. They know the body's height offset. Maybe I shouldn't. Well, I guess that is per leg, right? So I guess update leg should probably do that. It should probably look at where it is and write an offset at this point. And then solve on crawler character can go through, look at those offsets, and then do its more global stuff. I could also just write it in here. Update legs could do the leg offsets. Alright, I think I'm gonna put it here. Let me go and write down the process. So and it has the effect of also solving orientation. So the first step is, I'm going to do this really high level. I'm not going to do the super calculate the limited angular vector, right? So it's going to be for each leg, for each grounded leg, calculate calculate a height offset, which is from, which is the length of the vector. I guess which is the dot product of the legs ground vector with the vector pointing from the leg. Actually, no. Which is the distance of the leg's attachment point from the plane defined by the ground normal and contact point with the ground. Okay. So what we do for you. So each leg can just calculate that on its own. I will say this, within the crawler leg class. Okay, high offset from the plane defined by the ground normal and contact point with the ground. Withing. And also set this value to infinity when not in contact with the ground. Okay. And then within crawler character, I will calculate the mean offset of all grounded legs. And then I'll say, I think if I have at least half of my legs, perhaps, I can calculate a standard deviation and use that. Otherwise, I just allow every leg to probably apply whatever its max force might be. Just for now, I'll just say I'll compute a standard deviation, even if I end up with like 2 legs. Does that make sense? I think maybe what I should just say is that each leg can only apply a force equal to up to 5 centimeters of displacement, I think, or some small value, which should prevent them from being able to. A very compressed leg should not be able to overpower 2 legs neighboring it, because the best it could probably do in that scenario is it wants to push 5 centimeters, and the other 2 legs end up reaching 2.5 centimeters of difference, and then it's okay, right? It'll balance there, because then those 2 legs are pulling down with the same force that one's pushing up. If there wasn't a limit on it, then those 2 legs on the side might reach 5 centimeters, while that one has like 20 centimeters of displacement. So that one would just totally push off, right? Yeah, I'll skip the mean offset thing. I'll calculate a force limited to some well, I guess the force limitation should probably be I did also say 20% of the average. So if the average is like, if everyone's like at where they want to be, but one of them is really not where it wants to be, then the average will only be slightly higher. And so then I can say, all right, everyone can apply up to this much displacement. And then maybe I also say this much displacement plus some small percentage. Maybe just that. Yeah, maybe I'll just say this. Calculate the average displacement of each leg from the desired height offset. This will be the maximum displacement force. This will be the maximum displacement for all legs. Then I would calculate a spring force. Which, how can I get damping in there? Because they need to be able to pull too. Which means if I have like some... I use negative and positive, but I mean... Positive displacement would be we're above where we want to be. Negative displacement is we're below where we want to be. Right? If I imagine the displacement as like a flat line. Or just like a bar. And the attachment point is being above or below that bar. So it's below the bar, I want to push up. If it's above the bar, I want to pull down. And then I probably have like a window that it's allowed to be in. So well, I don't know. I can't really do a window because gravity can work inside of that window. So it might say, oh, I'm fine, so it will just drop, and then it hits the bottom of the window, and then it says, okay, now I need to push up. And then it will maybe push up, and then drop, and then push up, and then drop, and just keep doing that over and over again. No windows. Yeah, the problem is that I do need the velocity. I guess since I have state, I can ask for my global velocity at every point, and that gives me the perfect result. So I could just say, all right, well, what's my velocity at this point? Project that onto the ground normal, and then that's my spring velocity. And my spring speed. Calculate a spring displacement and speed. For each leg. The speed should be the dot product of the local velocity at the attachment point with the ground normal. Displacement should be limited to the average of all legs. Wait a second. If I have two legs, if I have three legs, and they're like this, that displacement is like +1, -1, and 0, which will be an average to 0. So I'd say the legs can apply no correction because we'll be limited to that. So this is probably where I say limited to the average plus some percentage of the original of that leg's value. Maybe this is where z-score should come in. I can have up to like 1 over that percentage, or some mapping of that value. So if we're at 1, maybe it's like 1/2. We're at 2, maybe it'd just be like the power of 2, be a quarter. Right. Or I guess maybe it's the absolute value instead. So in that case, the absolute value displacement would be 1, 0, and 1. The average would be 0.5. Calculate the average absolute displacement of each leg. This will be the maximum absolute displacement for all legs. And then apply. And also say, I mean, yeah, this actually handles it, right? Yeah. Apply the spring force to the attachment point of all legs. Okay, so within the crawler leg class, calculate a height offset. So I can do that. I have this attachment point, and then I can have somewhere around ground normal. I'll do ground offset, which will be infinity when it's not set. I guess I can just calculate it here, right? Ground offset will be the distance of the leg's attachment point from the plane. Yeah, okay. normal and a point on the plane. I do need hit position, actually. I'll just save it all. I wish clicking that actually worked. I don't know why it doesn't work. Because it brings me to like the first one, but not to the one that I clicked on. Creates a plane from the normal vector and a point on the plane. Yeah. Okay. The shortest distance from the plane to the position point. If the point is above the plane, the distance will be positive. Awesome. Point is below, the distance will be negative. Above is the plane is considered the side of the plane towards where the normal is pointing. Good. Perfect. There we go. And that's all that one needed. Since this is only angular velocity, I could go ahead and just move it down. So I'm going to go ahead and just move this one down. So we'll calculate it and then we solve it. So calculating will stash whatever. It will be able to do reading from state velocity prior to all the stuff that could change it. I prefer leg offsets, honestly. So what this should be doing is getting the body's local velocities at the attachment points. It needs to read that before it does any adding. Because definitely solve rotation will mess with that. It will definitely mess with that. Can I save this onto the leg? Perhaps leg can save this, because leg can just... Yeah, leg could actually just save it itself. So leg has its ground offset. It can also have its ground velocity. Which, here's a question. Should the velocity be measured from the attachment point or from the end of the leg? If it's measured from the end of the leg, it'll be a lot higher. The velocity will be much higher. I guess I can measure the velocity as the point halfway between the attachment point and the contact point. Maybe that makes sense. Because it should just be linear, right? Yeah, it probably should be that. The velocity halfway between the attachment point and the leg contact point. Well, actually, this is a leg velocity. Well, the velocity is the... I don't think I'm going to be using it here. So I think I just don't... I think setting it to 0 makes sense. I think setting ground velocity to 0 actually makes sense. Instead of infinity. For this case. If I do have ground, then I guess this is where I would calculate it. Also, this should move down, shouldn't it? Yeah, this should really move down. This should all be underneath that one. Oh, so how do I get the point halfway between two other ones? Did I just add them together and then divide by 2? I gotta look that up. I'm not sure if that's right. I mean, if I think about it, it is technically also that's the same thing as asking what's the average between 2 points. It would just be adding them together and dividing it. You just add them together and divide. Yeah, okay. Also, I said I would be getting ground velocity. I think the raycast gives me that, right? Nope. But I can obtain it. So get collider RID. Space state, what? Okay. Get velocity at local position. I need to read through this one to make sure I'm doing that correctly. Hit position minus ground state transform origin. Okay, so I take a global location, subtract its origin, its transform origin. Okay. So the midway point between attachment point and ground point. So I just add them together and divide by 2. Yep. Well, it's actually going to be this negative ground contact velocity minus state linear velocity. Way. It's trickier than that. It's going to be state, get velocity at local position. Yeah, I've done it all a bit out of order here. I'll write that so it's more clear that I'm doing this. So it's supposed to be ground state, get velocity at local position. Which, if I really think about what I'm doing here, I'm doing plus this minus this. So I've got it in a bit of a weird way. And I mean, if I think about this, if no object is intersecting the array, is colliding returns false. This can only be true if is colliding was true. So I always get a body, I always get a state. Yeah. Attachment point is relative to the body. Yeah, it's not oriented. Okay, so I have to do this. I have to transform it to get the actual global position. This one's always weird, including translation and rotation. I guess that makes sense. Which is why I only subtract the origin point. I don't know, it's odd. This one's been odd. I'm not sure this one always gets me the right answer, as I've written it. I think what I meant to do is probably take this point and it says translation and rotation, but I don't think that's true. Because when I jump on the spinning disc, this is what I do. I only subtract the origin. I don't translate the point. I don't rotate the point. I think they're just wrong. Because if it included translation and rotation, then I would have to take this point and essentially do transform, inverse, multiply by this point, is what I would have to do. That's not what I do. That's not what I do. I did learn that I just take the hit position and subtract the global. I'd subtract its origin point. And that gives me the correct values. When I would just take hit position, multiply, or the inverse transform, multiply by the hit position, it would give me some crazy results in weird places. It would just be weird. So yeah, I think it just includes translation. So when I give it a point, I'm giving it a point offset from its origin, is what I'm doing. So if it's spinning, I'm getting the point at wherever... What? When I stood on the rotating disc, this gave me the right answer every time. Just taking the point, a point in global space, and subtracting the origin offset. Gave me the right answer. I mean, I think that's just all I do. I don't think I... I don't think I account for any translations. I do account for it here because I need to... This is leg position relative to the body. So I have to transform it because no matter what orientation the body starts at, this is just like a relative point in the body's coordinate space. So I have to translate that to a global coordinate, which will get me, which is what this does. I get a global point here with the right rotation. And then I take the average point between these two, or the midpoint, and then I just subtract body's origin point. I don't know, it bothers me. I don't like how it... I just don't like it, but... I mean, it seems like it's how it's meant to be. I don't know, I just wonder if I have just actually been doing it wrong this whole time and there's just some math thing that I missed. It's just been weird because I have to do this too. I wish I didn't have to do that. I wish I just could give it a global coordinate and it would say, okay, well, let me translate that into my local space and then I can tell you what the velocity is there. It's the fact that I have to do this and they say rotation. When I only got the right result when I stopped including rotation. I only accounted for translation. Alright, well, I'm just gonna hope it works. It bothers me a lot, though. Okay, so now the lakes calculate their ground velocity and their offset. So I don't really need to do a calculate beforehand. I can just go straight to a solve, I think. And I don't have to do any of this I'm not doing any polygon stuff. So each leg is just calculating its own thing. If the leg is not grounded, I skip it. Yeah, I guess I said the first thing that I'm supposed to do is to calculate the average absolute displacement. I need to write this. I don't think I need to. Maybe I don't need to. So negative values are below the plane. Well, I mean, it's actually going to be always positive, pretty much. But I want to move it up. So yeah, if it's like 0.5 and I subtract 0.9, I'd get negative 0.4. So it's 0.4 below. If it was 1, I do 1 minus 0.9, it'd be 0.1 above, right? Okay, so that makes sense. Offset, and then the offset needs to be limited. So limit the offset to the maximum, or to the absolute, to the average absolute displacement. Maybe I shouldn't do that, actually, because I can have really small values. Sine of the offset times the smaller between so now that's been limited, and then the speed is very simple. It's the speed in the direction of the ground normal. So we ground velocity dot the ground velocity. That's the speed. And then there's all the spring forces. Okay, and then we can just do apply impulse. So it'd be total force times is it always up? Yeah, I think it is always up. I'm essentially treating it as a spring that would be straight down from the attachment point to... Oh, it's actually not quite like that. It would be... Well, that vector always points... Yeah, I think I was going to say it would be the vector of drawing this point up to that one, but it would always be... Maybe it wouldn't be. Yeah, it would actually be the vector of the ground normal, actually. It would be the ground normal. Yes, it would be the ground normal. And then applied at the leg attachment point. So now for solve rotation, I am going to allow all of this to happen, but I'm going to take off, I'm going to set angular x and angular z to be 0 for now. Interesting. Interesting. Okay. Why? Because it should have started to... Oh. What? Am I not applying gravity? No, I definitely am. Right? I'm applying gravity. Why does it float away and start bouncing like that? Why does it do that? Yeah, why is it lifting itself up? Oh, interesting. The average absolute displacement does not increase. That's funny. Oh. Duh. Oh my god. Okay. Not what I expected to see at all. Because I am applying the spring up to like 6 times, maybe what I do is I probably divide this by the number of, divide the force or the mass. By that proportion of it. Well, oh, this is total force. Right, so they actually are applying way too much force. It's more specifically that each one can apply up to... Also, I do clamp it, so it can't be negative. This should be allowed to be negative. I do want it to actually be able to pull it into the ground. It goes insane immediately. Essentially, I want to say if 3 legs are in contact, they all apply... They all apply a third. I want the legs to apply between a third and a sixth, depending on how many legs are in contact with the ground. I think is what I wanted to do. Also, should I get the average speed too? Okay, 3 legs, 3 times 2 over 6 is 1. 2 legs, 4. Sorry, yeah, 2 times 2, 4 over 6 is 2/3. I mean, yeah, I think what I'm doing is I'm just saying no, because the force is based on this. Oh, I think I'm doing a max. I think what I say here is for mass, I do a max between half the mass, or no, a third of the mass, and mass over count. Or no, the smaller value? So what does this mean? If I have 1 leg, it's a smaller value between mass over 1 and mass shared among half the legs. So if I have 6 legs, it's mass over 3. Okay. Mass over 2, half the mass, and the smaller value would be mass over 3. Mass over 4 legs, it would essentially just be mass divided by 4, right? So mass divided by 4 is smaller than mass divided by 3. Mass over 6 is smaller than mass divided by 3, right? Okay. Okay, so I have shared mass. Alright, that's a better calculation there. And then leg force is not... It's accounted for in the mass. Uh-huh. And it freaks out. Okay. What's weird is those legs should have been then pulling down. Why didn't they start pulling down? Like, why is it toppling? These three legs should all be pulling down because they're too high. And all these three legs should be pushing up. Why is that not happening? Why is it continuing to rotate? It is just continuing to rotate. That's very strange. I guess I can just go through that. Oh. It does have this weird wobble to it. But you don't even see that because of physics interpolation. Okay, let's try that again. Whoa, 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 whoa. Okay, so it's doing something super insane now. All right. Let's step through this and see how it is managing to apply such a ridiculous amount of force, because maybe I should not allow it. I have to allow it to pull, but maybe if it's a pull, I don't know. It is unstable. All right, well, I guess let's go through this. All right, this is the current frame. I guess I could look at all the legs. So it's thinking... Alright, this one has no offset. This is 0, which is the front left leg, which is this leg right here. So I guess that would make sense. I don't see a normal anywhere, so I was just going to assume that it actually does not have ground contact. So, alright. This one also doesn't have ground contact. Okay. This one also doesn't have ground contact. Alright. none of these legs currently have contact with the ground. Alright, I don't understand that, because then I'm not applying any forces here. Alright, I hit continue. Okay. My mouse is being aggressively captured by this window for some reason. Alright. This is the frame. See if any of these legs have contact with the ground. None of them actually do. At least not visually, to me, anyway. Execution resumed. No. Okay, here we are. Do any of the legs have contact with the ground? None of the legs are in contact with the ground. Okay. So nothing should happen. Alright. Like, I'm super confused. Okay, if we ever get here... Alright, this is the frame. Apparently, a leg is in contact with the ground now. Alright, well, I think, first of all, it's pretty obvious that it's just gone wrong. Oh, hey, Eris Ezra. Thanks for the raid. I'm just gonna try running it again. Once it does something weird. Hello, we bring chaos. I don't like chaos too much. I like being calm. That goes deving. Pretty good. You know, every frame, this is what's happening. So, something's going wrong. I'm trying to figure out why that's happening. Okay, it's doing it now. And then I'm grabbing the wrong windows. Jeez. Alright. Coleman Orley is lovely. Yeah, right. Now, I mean, you can see what's happening to it. This one's pretty chaotic. Eris Calm is like the opposite of you. Calm is okay. Right. What were you doing, Eris? I've got 3 legs. I see 4 normal vectors, which tells me my debug is not good. Okay, what's average displacement? .28. The average absolute displacement. Working on character animations. This project looks interesting. Yeah, I am working on what I think is the hardest part of the game, which is this crawler first. And then the idea is I can either... I figure that out, and then everything else is going to be easier after that. Instead of doing easy stuff first and then hitting something really hard and realizing that I can't do that. Not that one. 0.87. 0.8. Wait. Not that one. 0.8. .85. What? Oh. Add. There's no way that's the problem. Okay. Yeah, okay. It's... I don't know what's making it so unstable. But it gets really bad very rapidly. It looks fine. Okay, now it doesn't look so fine. It looks like it's... Yeah. Maybe I just divide it in half. I don't know. Because technically what's happening is that one side is trying to... Okay, and then now it's not enough to lift itself. Okay. Why? Yeah, a lot of what I do is just sit here and wonder about what's happening. And then maybe eventually I get... Well, not maybe. Eventually I figure it out. Something about my assumption here has been wrong. I thought this would stabilize. It's already unstable. Like, that's an incredible amount of force, though, isn't it? Right. I do that. No. Really? What? That. Yeah, so what's happening is this value is steadily increasing. Right. Which is actually not, like, doing really badly. But it still can't correct itself. Yeah, like that. That's just insane. I thought I was limiting it. I mean, I guess I didn't do that yet. Maybe I should limit this to be like 10% of the height offset. Just for now. Like, I just don't want to see that happen. That's just crazy. It could be the speed. All right, I'm going to go look at the source code for this. This is something I haven't been certain of. That I feel like it's just always been wrong, or like I'm using it wrong. Because it doesn't make sense, and I'm not translating things how I think possibly it should be. Get velocity at local position. Body get position plus local position. If you add the Gmod ragdoll sound effect, it would probably be fine. Yeah, it does just look like that. Get motion properties. Get linear velocity. Angular velocity. Center of mass. Angular velocity cross center of mass. Interesting. I didn't know that's how that worked. Okay, so I think I'm right. Yeah, I don't account for rotations. I just translate it over, and then that's all I do. Oh, I don't know. It's just it is really. I feel like even having the force shouldn't have made it do that. Maybe if I just bring this back to 0. But I technically can't leave it at 0, because it needs to be able to pull into a wall. Like, what's happening here is this leg is pushing up still. It's rotating. This leg is pushing up. Why is this leg pushing up? Okay. So I've definitely got a problem happening right now. I have a leg pushing up that should definitely just not be pushing up, I think. Or I don't know. It definitely looks to me like the leg over here should be providing way more force up than this leg over here is. Also, what's strange is why doesn't this, like, tip it forward? Why is it not tipping forward? Wait, why is it not tipping forward? Shouldn't it be tipping forward? Why doesn't it tip forward? Did I do this wrong? Oh. Wait, is that right? Okay. I think maybe I say, maybe I just turn this off completely. Maybe I just don't allow it to rotate at all right now, because this might be causing the problem. Okay. Well, at least there's less that it could be. Yeah, see, it's tipping right now, which I thought it shouldn't be tipping. Because then this leg sees and says, oh, I shouldn't be pushing so hard because I'm not low enough. But this leg will be like, oh, I gotta push really hard because now I'm too low. And it kind of doesn't... Yeah, and then now it's just about... It's going to totally flip out of control and spin like crazy. So... I must have a bad calculation somewhere. Alright, see, these are legs that have good offsets. Alright, so this is front left leg. To me, in my mind, this should be a negative offset. I should see a negative offset. Okay, subtracting 0.9, that's a negative offset. Okay. Next leg. I guess counter position probably means it's going to be index 1. So this leg, I would expect to see a positive offset. So value greater than 0.9. It's below 0.9. Which, I mean, I guess that's fine. The other one is still going to be applying way more force. Or it should be, at least. Is that part of it? Let me write 0.2. Here, one. All right, it's going out of control now. Why? In my mind, I thought that I'd be able to turn off rotation corrections because this should technically solve that. But it's obviously not. It's getting it's accelerating in rotation. I mean, yeah, it definitely is just accelerating rotation. These ones, the other legs are not applying enough force to counter it. And then this happens and it gets like a huge acceleration. So is it like the speed is wrong? Maybe it's the speed is wrong? They think they're damping, but they're damping in the wrong direction. So I'll try to see if I can spot it on about the frame that they kind of become super excessive. All right, so I'm thinking about here's the point where it's getting to be super excessive. All right, so this is the front left leg. I would hope to see some positive force in this direction, but also with a speed that's not ridiculous. Okay, it's probably ridiculous at this point. Ground velocity, that doesn't make any sense. I mean, I guess it does make sense. Maybe I should be measuring the velocity at the point. No, I don't think so. It seems like I should measure velocity as if to be halfway between the leg and the... Maybe that's not correct. Maybe it should be halfway between the attachment point and that ground point. Maybe that makes more sense. So I want attachment point and then add, I think, ground normal. Yeah, if it's halfway between these points, then it would be ground. Ground. I essentially want to go halfway to the ground plane, I think. All right, you know what? For now, it's just the attachment point. It's just the attachment point. I really don't think that fixes it. This might make it a little more stable. Okay, I guess not, because that definitely got worse way faster. Never mind. Alright, skip that step. Alright, now it's accelerating. Okay. All of its legs are firmly planted. So now I want to know... what are they thinking? Okay, front left leg. I would say it is going into the ground, so this ground velocity makes sense. Maybe the damping is too high. I don't know. I don't think the spring values are a problem. I don't think they should be a problem. My thinking is that somehow it's accelerating itself into the ground. The left side gets compressed a little bit and it says, oh, we need to accelerate more. And then that damping creates more acceleration. But I guess it's also not pushing itself into the ground. It does just kind of rotate in place and spin out. I was going to say, all right, I don't fully understand why it's spinning out right now. I should understand that first before I continue. My thinking is that it's probably just something fundamentally wrong. I don't know. It's either something fundamentally wrong or I have like a negative sign somewhere that I shouldn't have. Okay, so offset. Offset is now calculated as negative 0.1, which makes sense to me. The speed is like ground normal dot the ground velocity. Speed is like negative, yeah, about -1. Okay. Spring force. I expect a positive value. Positive value. Damping. I would also expect a positive value. Okay. Because it's accelerating down, so it wants to stop accelerating down, so it will push itself up. And then, yeah, then total force is just the sum of those two, and I just have this multiplied by 0.5. Because I was thinking maybe that would help it. And then it applies the impulse. Okay. Alright, so next leg, this is the front right leg. So I would expect this to probably, it would want to push up because its offset is still negative, but its velocity is really fast, so it should want to pull down pretty strongly, I think. So I still expect to see a negative offset. Very, very small too. Almost nothing, right? Speed, I expect to see it being positive. Okay, so it's a much higher positive value. So when all this is said and done, this should be a negative impulse to pull that side of the body down, is my thinking. Right. So I should end up with a negative, and I don't get negative total forces. I only can have a positive force. So it ends up being 0 for this leg. So it should stop accelerating. Right? Okay. I'll skip ahead to leg number 3. So I would hope to see the same thing again. A slightly negative offset, but then a very positive speed. Very, very positive. So then it should come out to be 0 force. Okay. Technically, I do have to allow it to be negative for it to stick to surfaces, but for now, I just have it as 0. So yeah, so this one also does nothing. And I want to go to 5. I also want to see 0. 0. So, like, what I'm expecting to see is that if those stay the same, then this should start... It should start going back the other way. Or go up in the air. One of the two. Just take this off, and that happened. And now it's accelerating. Why? Why are you accelerating? It's definitely just getting worse and worse. Okay. So what's happening now? Oh, wow, it just counteracted. It just went back the other way. Or at least I think it did. I don't know. Technically it hasn't done anything yet. I think what I just saw was just physics interpolation. Okay. Front left leg. Only 3 legs are in contact with the ground, so it's just all the left legs. Should be applying forces. Is that the problem? Does this have to be translated? Position is the offset from the body origin and global coordinates. Is that possibly what the problem is? This is the wrong... This is a little bit incorrect. Okay. So what I'm thinking is I do... that. It's way more stable now. Dang. Wow. How did I see that, though? I don't know how I saw that. I don't know how I saw that. What if I just let you be full force? Also, and I let you be negative. Negative now. Alright, what if I bring your rotation back? And like I said before, I will turn these off. It is, you know, there is something with the legs, which I can still fix, where the legs, like, kind of stop moving. But as long as this is generally getting it correct. And there's a wobble, which I like. I was wondering if I would see a wobble, and there's a small wobble. Whoa, what was that? That was weird. He kind of accelerated really hard there. Can you stabilize without falling? It is kind of keeping itself off the ground, though. It is falling. Oh, it doesn't actually have anti-gravity yet. So it will just continue to fall. But it kept its body off the ground as it went up that. Can you go over there? Before I do that, I'm gonna turn off this printing. I wish I even under... How did I think that was it? How did I think that was it? Go all the way up there. Good luck. It should hit the stairs. But it should be able to walk over it. Whoa. Whoa. Okay, so I got really tripped up. But... what are you doing? Alright. It's fine. Go up there. It's definitely some leg work, I think, but oh, and it ran through it. Whoa. I kind of like how it looks like that, though. Why does it run into the wall like that? Why are you doing that? Can you go slower, maybe? Maybe slower would help. Maybe it does need to have, wow, it's really just not... Why is it doing this? It's definitely does not like the legs being over there, I think. I think that's probably the main problem. The legs being slightly elevated, it really can't figure that out. But when none of the legs are, then it's kind of okay. Will you just look at me? Okay. Forward a little bit. Oh. You okay? Ah. I think I understand. So... when one of its legs is up like that, it's technically reading the ground as being higher than it. Well, it should be reading that it should do... It would want to do a very large push up. But it seems like it can't. Like it wants to go into the ground. Because that side is dropping. Right? It's really... odd behavior. Yeah, see, it's falling into it. Somehow it's not able to push off. Honestly, I kind of want to call this a success so far because it's not spinning out of control anymore. Is this fully physics-based? Half and half. So the animation for the legs, it's I'd say, okay, it's like cheating full physics, I guess. There's a lot of cheating happening, but a lot of it is physics. So the crawler is a physics body. It's a rigid body. So I'm only moving it by changing velocities. I'm not actually translating it anywhere. The leg poses are IK, but then the actual location of the legs is, like you can see now, it's trying to correct itself using springs, essentially. It is treating its legs like springs. So that's why if it walks towards me, I don't know how obvious it is, but it is wobbling a little bit back and forth as it walks. And then I just have some issues that are like kind of left over from how I slow the legs down. But I can push it. Right. My character is also a rigid body in the simulation, so I can push this thing around. Which is part of what I want. I want this to be possible. I don't understand what it's trying to do right now. I think it just wants to face that direction. Yeah, okay. I'm quite impatient, so I usually give physics a go, then rip it all out. I really wanted physics, or I really want physics because I want you to be able to physically... I want you to be able to shoot legs off of these guys. I want pieces of themselves to fly into others and knock them around. So that's what I'm trying to do. I'm trying to make sure that anytime that this body needs to move, I need to make sure it's happening within a physics simulation. So part of that is making sure that it balances itself during physics, and that all needs to be based on like where its legs are. But it's weird right now. It's a bit weird. Is it really not gonna? Okay. Honestly, I think I might just, yeah, I think I'm going to send that and call that for today. Because it's there. It is spiritually there. I think the issue is that its legs are just not doing very well. I wonder what happens if I leave this in. Does that help if I leave this in? I do like that so far it seems to be able to correct itself if it totally flips over like that. Though that's not a guarantee. I have seen it stand upside down. I think I might just be getting lucky. Or I got really unlucky that one time it stood upside down. Okay, I think it's not going to be able to recover at this point. So strange. Alright, let's try the ramp. It's interesting that it can interpret upside down as a goal. It doesn't have any concept of upside down. Oh, wow, it seems to be a lot more stable now. if I allow it to. Okay. Technically it shouldn't have a problem going up that vertical ramp. If I click up there, it should just be able to go there. It seems to be having a problem though. I'm not sure why it's having a problem. Oh, it's still okay, yeah, I forgot. It doesn't actually have anti-gravity capabilities, so it still can't go up the wall. Never mind. All right, what about if you go up the ramp? I feel like you're not going the right way. It can't deal with moving platforms yet, and by deal with it, I mean it just pretends like they're not moving. What if you go up there? Okay, it still does that. I wonder if I just need the raycast to go up higher? Yeah, I think it's just, it really can't deal with that. With legs being like that. Okay. Alright, I have no idea why that would be the case, to be honest. Well, I mean, I have an idea. I don't know how to solve that. I thought maybe turning this back on would help. Wait, did I actually turn it back on? Oh yeah, I did, because it's rotating. Yeah, I just don't know why the raycasts are doing that. Alright, it'll probably just be like fiddling with stuff. Okay, I'm gonna call it there for today. Sorry for a short day. And also, yeah. That's gotta be it. I feel like I have a good stopping point. So. How did you got 17 views? I thought you were only... I was your only viewer? I just got rated, so... that would be why. I could turn on anti-gravity and see. Was it desired acceleration equals... I'll see. Should make sure I line it. I need a crosshair really badly. Go up there. Alright, he overshot it. But it seems like if I turn on anti-gravity, you can kind of handle it. Sort of. That's great. Okay, it's leaving a leg behind. I don't know why it's doing that. It can't rotate anymore. Yeah, you know what? That actually makes sense to me. I see why it's doing that. I prevent it from rotating if any leg is off the ground. I should probably say... like, if I have 4 or 5 legs, he can rotate. Why does he seem to, like, accelerate so dramatically at the end? Okay, now it's standing upside down, which is really odd. I think it's floating away. Okay. Alright. Yeah, that's enough of that. It's close. It's close. It's as close as it's ever been. You viewbot as always? No. Nope. Spring-like force to keep the center of mass some distance away from the ground. I have done that. Although I said I was supposed to do anti-gravity first. I'm just crazy. I have an extra space at the end of some line. I don't even know why it let me do that. Okay. I think I'm just adding everything. I think everything is necessary. All right. Add height, body height offsets, offset for crawler. Crawler now keeps its body off the ground. Also has the effect of replacing the general directions for rotation. Probably not keeps it real and based. Is that really all this is? I think so. Yep. That's that. All right. Well, I'm done for today. It looks more it looks more. Let me turn off debug. I do really like that it has had the extra effect of right, crawler leg defaults. Close that. I really like that it has the effect of doing a little bit of, like, bobbing while it's walking. Its legs still get stuck. That's just kind of been an issue that I've had for a while, but I haven't, like, really fixed it yet. Because they just have a bad assumption of when the body's in motion and when the legs should slow down. Mostly relating to when it stops, of course. It thinks it's in motion because it's slightly rotating, so it is waiting for other legs to be grounded, but the legs can never get there because they're also really slow. But nice. It was nice. It's getting there. It's getting really close. I think really all it is now might just be doing tweaks to make the legs not slow down so much. I think it's probably the problem. I could see that right now. Let's see. Like 8 or something. You know, it's still weird. It's still weird. Yeah, I'll have to figure out what that is. Alright, so I guess I need to get anti-gravity, and then wall climbing is technically there, and then I have to fix stuff. So I guess the first thing is probably... fix leg stalling when stopping, and then there's also... it just behaves weird when a leg is too high. Investigate weird behavior with legs elevated above the body. Legs go through the ground. Legs go through the ground and don't lift at all. And they should be lifting a lot. Okay. That's for tomorrow then. So yeah, thanks for watching. I'll be back tomorrow. Goodbye.